There you are.
Hey,
Hi, Ashley. Welcome, and thank you for jumping in and volunteering to present at BrisJS.
Oh, that's awesome. I'm always happy to present for BrisJS. Hi, everyone. My name's Ashley Davis. Today, I'm going to be demonstrating how to use live reload across your stack, which can help you be a more efficient developer. I've recently written a blog post about this. It's going to be called something like a complete guide to live reload. So that's not published yet, but it will be published. It will be published soon. And tonight I was just going to be skimming through the content because there's quite a lot. But hopefully I can go into a little bit more detail now because unfortunately Andre's dropped out. So I've got a little bit more time. In fact, I'm just going to start my timer because I don't want to go more than an hour, that's for sure. And I don't actually know how long this talk is going to go now because I cut stuff out of it already, but I can put that back now. Now, if you get lost in the details a little bit tonight, don't worry too much about that because you can come back to my blog post later and you'll find more detailed descriptions all written down there, and you can kind of jump to any section you want to kind of look at the bit that's going to interest you, because I'm covering full stack. I'm covering everything to some level. Now, every code example that I'm going to show tonight, it's available on GitHub. I'll show you that in a second. So I would really encourage you to kind of get the code and try this out for yourself. Hopefully it's not too difficult to get it up and running and see for yourself, what this is all about. All right, I'm just going to share my screen. Cool. Hopefully everyone can see that.
Yes, coming.
Cool. All right, just a little bit about me first. I'm sure you've seen me on BrisJS before. I probably don't need to go through this. And my startup has had a name change. It's called Hone now. So I'm the VP of engineering at Home. We're building a DeFi product on the Algorand blockchain. And hopefully we'll have more about that on our website at some point in the future. I'm the developer of DataForge Notebook, which I'm open sourcing this year. I've written a couple of books. You've probably heard about those before if you've seen me on here. Currently, I'm writing a new book, Rapid Full Stack Development. Why am I writing this? Well, I personally believe it's not enough just to kind of fumble through and survive as a developer. I really want people to be able to flourish and really get into their career and, really become effective at what they do. And this book, Rapid Full Stack Development, it's going to satisfy that need. So that's in progress now. If you want to learn more about it, please check out the webpage there. And if you want to keep up to date with what I'm doing on it, follow me on Twitter. So, what is live reload? Getting feedback quickly while you're coding, it's a really fundamental and, as Kevin said, an essential part of development, really, of what we do. And I think it's something it's really at the core of having a rapid pace of development. Now, writing code quickly it's not our only concern at all. The code that we produce, it has to be also valuable and reliable. And, only you or your company can really decide, what it means for your code to be valuable. No one else is going to tell you that. I certainly can't. But how can your code be reliable? For your code to be reliable, that is something you need to test for yourself. And, you need to be able to run your code frequently, and you need to be able to get that feedback really quickly so you can check the output and the behavior. Now, we can create a much more faster and seamless workflow by having our application automatically reload as we're editing the code for it. So that's what we call live reload. You're in development, you're editing the code, and whatever you're running, whether it's like a front end or a back end or something in between, it'll automatically reload as you're working on it to give you that quick feedback without you having to manually restart anything. So in this talk, we're going to examine a variety of full stack techniques for live reload, and they're going to really automate, the run it part of your development pipeline. So wise use of these techniques, that's going to help you become a faster developer. Live reload, it's the automated approach to restarting our application in development. We do this so that our application automatically picks up code changes while we're coding. And this is just something that, if you've spent any time kind of coding and having to restart your server or kind of refresh your web page that you're building or something like that, you know that this is just going to save many countless hours of manual and tedious restarts. And it's going it's going to help you test your code. Like that's what it boils down to, really, is to see the output of your code and to be able to test it. You've probably heard of live reload already, and that's because it's quite typical for developers to use live reload when they're building a web page, and most common kind of front-end frameworks include some sort of support for live reload. But you might not know that we can apply this across our entire stack. And you can see in the diagram here, the part of it that it's labeled, this part can be automated. That's the part where live reload fits in. That's where it's going to automatically detect the code changes you're making and then rerun the code for you. So this is where live reload fits into the coding cycle. Now, if you don't have time to read all these diagrams, that's not really the intention. Don't worry about it. These are all from the blog post. So you will get to see these, and I will show you where the blog post is going to be in just a moment. So this diagram shows the coding cycle unraveled over multiple iterations. It's like a bird's eye view of the ongoing process of development. Through this process, we take our code from working state to working state, accumulating working code and minimizing the buildup of bugs. Any improvements that we can make to each small iteration of coding here are going to have an amplified effect across our overall development process. So live reload, it can have a dramatic effect on your performance. And that's not just because it kind of automates these boring and tedious restarts of your application or your processes, but it's because it can basically scale it up across your process. So like you might have multiple front-end parts, multiple kind of sets of automated tests running. You might have like a backend with a ton of microservices running or something like that. You change a line of code anywhere, and anything that needs to restart will restart. It'll just figure itself out and restart. So that's the power of this. It can be scaled up across everything you're developing, everything that's part of your project, all across your stack. Now, of course, because it's actually being scaled across all the kind of iterations in this pipeline as well, it's automatically scaled out kind of that way as well. Live reload also has the positive side effect that it encourages small changes and frequent testing. So both of these things will help you develop more reliable code. So all these benefits considered, it's why live reload is really part of the bedrock, the foundation of my development process. It's part of my philosophy of coding, and it's one of the core techniques that I'm including in my book, Rapid Full Stack Development. Before we get into the code examples, I just want to point out as well that these live reload techniques presented here, they're only to be used in development. So our needs for production are going to be quite different. For instance, I'm going to be talking a little bit about Docker towards the end of this talk. And in production, with Docker, we want safe, secure, optimized, and immutable Docker images. So that means we want the code basically baked into the Docker image. But in development, we'd prefer to have code that's not optimized, code that's more understandable and debuggable, and where the code is, this is the essential point, where the code is mutable. So if we want to get live reload working with Docker, which we do, and I'll show you that at the end, we can't bake our code into the container. So the code has to be mutable, and this is for development only. So my point is that production has a whole different set of concerns in development, and we'd like to treat production differently. So just keep in mind that, throughout this whole talk, I'm talking about development only, and maybe in the future sometime I'll talk about, production concerns as a separate talk. So we're going to start looking at some code examples now. And for each example, I've got like a diagram that's a bit of an explanation. And then we're going to look at the code and we'll try and run it. The first thing we're going to look at is using Nodemon to implement live reload for a really basic Node.js application. This is going to be a Hello World application, so nothing complicated. Now, Nodemon is a package that runs under Node.js, but it's best to think of it as a drop-in replacement for Node. And by this, I mean, instead of running like Node and your script, you can run Nodemon and your script. And then Nodemon will take care of the automatic reloading part. It'll detect the changes in the code, and it'll reload that code and restart itself. So it's pretty simple, actually. This is a pretty simple starting point. And under the hood, of course, Nodemon is just kind of running under Node anyway. So it's, it's not much different. It's just augmenting the way Node works. So I'm going to switch over to look at some code now. First of all, I'll show you where you can get the blog post and get the code as well. So this is my blog, codecapers.com.au. In the coming weeks, I will get this blog post published. It'll be really, really thorough. So keep an eye on this on my blog if you want to find that, or just, if you're following me on Twitter, I'll be putting the news on Twitter when that comes out. The example code's already complete, and you can run it today if you want to kind of follow along. So if you look at my GitHub page, Ashley Davis, and then live reload examples, there's like 9 examples here. We'll probably we might get through most of these tonight, seeing as I've got a bit of extra time, hopefully. So, feel free to grab this for yourself. You can either download it, download the zip file, or you can clone it by copying this URL here. And so if I was going to clone it, I'd go to my terminal and I type git clone, whatever it's going to be, to get that. Now I've already got it, and I've already got it open in my terminal here, so I don't need to kind of bore you with the cloning process. But yeah, git clone and the URL. Get it for yourself, and you can run it alongside me. Oh, I should note I am running Windows 11, but most of what I'm going to show you tonight will work on Mac OS and Linux. There's like one small bit, but when we get to that, I'll point that out. I'm running Node version 16, so you need Node.js to run most of these examples. The last 2 examples are Docker, so you'll need Docker desktop installed to run those, and it's not too difficult to get all that stuff up and running. I do have, you'll notice I'm on Windows, but I'm using kind of Linuxy or Unixy style commands. And that's because I've got Git for Windows installed, which I think if my memory serves, that's where all these commands come from. But it basically means I get to pretend Windows is Linux, which is kind of cool. So again, most of what I'm showing you is going to work on Mac OS or Linux because of that. So let's go into the first example. So normally what you do, if you just clone this code, what you have to do for each of these numbered examples is do an npm install to get the dependencies. In this case, the only dependency I think is Nodemon, so there's not much to get. And I've already pre-downloaded it anyway, so that's why that didn't take any time. I'm going to open Visual Studio Code from this directory. And we'll do sort of a quick overview of the project here. So there's not much in it. If you just look at the index.js to start with, you'll see that it's just a hello world program. And I can, even without any live reload or anything like fancy added on top of this, like I can run this by running node index.js, and you can see that it prints hello world. So nothing too exciting yet. Now, every Node.js project has a package JSON file. So this is where the metadata for the project is held. And you can see that the dev dependencies here, we've got Nodemon as a dev dependency. So I'll do a quick aside now, actually. In case you want to set this up for yourself, you would run npm init-y. That will create the project, the package.json for you. And then you can install Nodemon as a dev dependency by running npm install save dev Nodemon. And that'll get, so that's all I did, literally all I did to set up this project. So there's nothing to it. And then I created index.js and I kind of did a console log hello world. So really simple starting point. I just want to show you how simple it can be to use live reload with Node.js. Obviously this would be like a backend service, like a microservice or some kind of server. But it's, in this case, it's hello world. It's not doing anything. So the other thing that's interesting in the package.json is the configuration of the scripts. So I'll come back to that in just a second. I just want to show you how I can run this without configuring anything, how I can just run Nodemon. So I've got Nodemon installed, and I can run npx is a command that comes with Node.js that allows us to run locally installed packages. So I can use that to kind of run Nodemon and with index.js. And now what I'm going to do is I'm going to put my terminal side by side to my code, and I'll change this. So I'll change this to hello computer. And you can see that it's instantly restarted over here on the left. I've saved my code and it's instantly restarted. I could change it back to hello world, save that. So that is the basics of, sort of backend live reload in action. That's all there is to it. But you can imagine as this code, this project, this application gets bigger, there's going to be a lot more code in here and it's going to do a lot more, but it's still going to work essentially the same. Now, in package.json, we've got our script section here. This allows us to set up a start script. So this is the conventional way of kind of telling npm how to run your program. And so you can just run npm start, and it will run that whatever the script is there, which happens to be node index.js, and that prints hello world. Now this is a good way of working, because any Node.js developer, as soon as they get your project from you, they're going to write npm start. They're not going to know to write node index.js or node server.js or node app.js or whatever convention you happen to use for your main entry point. Even though index.js is a fairly common name for an entry point in Node.js, but any Node.js developer is going to run npm start and expect that to work. So that's a convention you should always follow. Now this next one here, start:dev, that's my personal convention, although I've seen other people using it as well. Maybe I've, back in the past, I found that from someone else. I can't even remember. But this is what we use to run Nodemon. So to run that, what we then do is go npm run start dev. So this is what I always use, no matter what project I'm using. Running npm run start:dev runs it in live reload mode, and then we can change our code or whatever and have it automatically live reload for us. So I don't think there's anything much to show you else in this first example. Oh, one thing I'll point out, that Nodemon is very flexible, right? Actually, I'll show you that. I'll just show you that briefly in the second example, which I'm not going to run, but I'm just going to show you what's going on in the second example here. So this example shows how to configure Nodemon. So it's essentially the same as the first example, but this time we have a nodemon.json file. So this is a configuration file for Nodemon. In the package.json, this time around, we're not telling Nodemon which file to run. So we've delegated that to this command, the exec command here in the Nodemon configuration, which tells Nodemon to run node and our index file. And we can also do some other things here, like we can tell it exactly which files to watch, including which file extensions. We can tell it which files to ignore. So if we want it to ignore, say, our automated testing, which will have their own live reload system. And I'm going to show you that in a moment. But the interesting thing that you can get by just understanding this configuration file is that Nodemon can literally run anything. And I myself have used this in the past to create like live reload data processing pipelines where you have Nodemon watching CSV files. And whenever the CSV files change, you kick the code in again to update them. So it's a very cheap and probably nasty way of creating a data processing pipeline that automatically reloads as the data changes. But the point is that you can Nodemon is very flexible. You can kind of run it on any file type, and you can practically run any command with it. So I just wanted to do a brief aside there in example 2. Actually, before I get on to the next example, which is TypeScript, I'm gonna flip back to my slides. And we've got a slide for TypeScript. Awesome. I knew I had one. So I'm a fan of TypeScript. I was going to skip this if I didn't have time, as much time tonight. I was going to skip the TypeScript parts of this, but I'm glad I get to keep them in. So using TypeScript with Nodemon, it could be very difficult. You could imagine that. You might think that you'd have to kind of build the TypeScript code to JavaScript before restarting the application. And that's certainly possible. It's certainly possible to kind of wire up a build pipeline that way. And it might require multiple build commands or multiple commands running in parallel. Now, fortunately for our purposes, there's a package called TS Node, and TS Node is like another drop-in replacement for Node.js. And essentially, it's a package that runs under Node.js. But I just find it helpful if you think that if it's a replacement for Node. So instead of running node index.js, now you can run TS Node index.ts and run your TypeScript code like it was running directly under Node.js. Now, again, this is for development only. It's kind of quite slow to work this way. It's a lot faster when you've got live reload enabled and you've got it constantly automatically reloading. It's actually really fast. But using TS Node, it makes it just so much easier and quicker to work with TypeScript during development and doing prototyping and just quick desktop scripting and stuff using TypeScript. probably makes it easier to learn TypeScript as well, because you don't have to worry about that build pipeline. So this diagram here shows how we can run Node.js basically under TS Node, which in turn is going to be running Nodemon. Now, basically, the way we're going to set this up is that Nodemon is going to be watching our TypeScript files instead of JavaScript files. And when they change, it's going to restart TS Node, which of course is going to restart Node.js and reload our code files. Okay, so let's have another look at the code. So I've gone into the third example this time. Just opening Visual Studio Code from there. And what can we notice here? Now, there's all the usual stuff in a TypeScript project. Again, it's just a hello world, but it's got a, you can see it's TypeScript because it's got a type there. Like, that's the only reason it's TypeScript. It's not we're not really making use of the full benefits of TypeScript in this hello world application. But there's a TS config, so this is the configuration file for TypeScript. We've got the Nodemon configuration file. We've got the package.json, which is the project file, the metadata file for the Node.js project. If we have a look at that down the bottom in our dev dependencies, you can see that we've got Nodemon installed, we've got TS Node installed, we've got TypeScript installed. Again, creating this project from scratch is fairly straightforward. It's just the npm init-y to create like a blank package.json, and then do an npm install save dev for any of these dev dependencies that you want to include. And of course, also here we've got like a bunch of scripts that make it just a bit easier to kind of run the different things. I'll come back to those in a moment. And in the Nodemon configuration file, you can see here that we've configured it this time to run only on code files that have a TS, a TypeScript extension. And for our exec command, this time we're running TS Node against the TypeScript file. And let's just try running this. So the start command that I've got for this relies on it already being compiled. Now, to compile it from TypeScript to JavaScript, you've got to run the build script here, which you can see runs the TypeScript compiler. It runs it in incremental mode, which makes it a bit faster the next time you run it. So let's just have a quick look at that. So I'll do an npm run build. Where does that? In that produces JavaScript files, index.js into the build directory. And from there, I can do an npm start and I can run it. So this is like, if you want to run it in production, this is the way you do it. Live reload isn't enabled at this point. Now, to run it with live reload enabled, I will use my convention start : dev, which runs Nodemon. And then if you look in the Nodemon configuration, you'll see that it runs TS Node and points it at my index.ts file. So let's run that. npm run start dev. And now, fingers crossed, the demo gods are smiling on me. I should be able to edit this code and do like a hello computer. So you can see that that's automatically restarted. It's running direct from TypeScript. So just to prove that it's doing that, I'll delete the build directory. So there's no build directory there. I'll run him again. So you can see here that it's printed hello computer. Let's run the program. I'll just get out of it. There's no build directory there. So I didn't bother like pre-compiling my TypeScript to JavaScript, and it all worked fine. It just ran the code directly from TypeScript. So it's just a great way to run your TypeScript code. Okay, now we get on to the next example. So this time we're going to look at live reload with Jest. So why Jest? I happen to use two testing frameworks at the moment. I use Mocha for some older projects. I tend to use Jest for all my newer projects. Jest isn't perfect, but it's pretty good. It's pretty good. It's a pretty good tool for developers, and it's pretty easy to initialize it and configure it. Like I think it's npx jest -- init will create like a default, a stub, a configuration file for you, and I haven't changed since that, so I haven't done anything to configure live reload. Live reload just works out of the box with Jest, so it automatically knows to watch your code for changes, and then we'll rerun your automated tests as necessary. And it's just a great way to develop. Have your actual application on one screen, have your automated tests on another screen, and have your code on another screen. And if you've got the screen real estate, you can't beat working that way. All right, let's have a look at how we use Jest. So I've gone into the fourth example here, just opening Visual Studio Code from there. Now the thing I've already installed Jest in here, and if we go into the package.json file, you can see the dependencies. We've got Jest and Nodemon, so we can run this in either way. We can run it as the Node.js application. We can run under Nodemon in live reload, or we can run our automated tests under Jest, also with live reload. Now, if you wanted to run it directly, you'd run the Jest command watch. Actually, that's not going to do anything, probably, because normally the way Jest works is it will only run tests for files that have changed from Git. So if this thing ever starts up for me. Yeah, so it's saying there's no tests to run, but don't believe it. It's just because nothing's changed in Git. But so if I make a code change, let me just do that. I just put a line in there and changed it, and now it's running my test. But I could have also hit the A key. The A key will force all the tests to run. So this is just a really kind of trivial Jest test. Expect true to be truthy. Of course, it's going to pass. I could make this false and I could fail it. But you can see that as I'm changing the code on the left, my tests are just automatically running and giving me really fast feedback. I'll change it back and we'll get that going green again. Okay, so back to the package file. Let's look at what scripts we've got. So the start and start dev scripts are like the same as the previous project we looked at. Nothing much has changed there. Now we've got the addition of test and test : and watch. So test means that we could run this manually once off. So this is running the tests without live reload. We're just doing a one-off run through of our entire test suite using Jest. But the conventional way to do it is to implement this test script. And whatever you're using, whether it's Mocha, Jest, Cypress, or any of the other testing frameworks, Jasmine I used years ago. Now we can run npm test, and any Node.js developer should know when they get your project that npm test will run the automated tests. Now, test : watch is my personal convention, and it's what runs Jest with the watch flag, so enabling live reload for Jest. And I can run that by doing npm run test : watch. So again, if I break my test somehow, it's going to tell me it's going to put a big screen of red in front of me. Let's get that passing again. Okay. Now I'll close down VS Code and we'll look at the next example. So I'm running through this pretty quickly. Again, if you're getting lost in the details, hopefully you're not. Hopefully you're following along. Hopefully you've got the code. Hopefully you've got the code from GitHub and you're running it yourself. But otherwise, hit me up on Twitter later and have a look at the blog post when I've got that out. So the next example is how to use TypeScript with Jest. Now, again, just because I love TypeScript, who doesn't? So previously we used TS Node to run our TypeScript code directly under Node in development without having to compile it to JavaScript first. You can imagine that, when we're doing automated testing, if we had to kind of constantly build our code to JavaScript before we ran our tests, that could be really tedious. But fortunately, we have a plugin called, or a package called Jest, which you can see in the diagram here. So that's like a plugin that runs under Jest that allows us to directly run TypeScript code in the Jest testing environment. It's really convenient, otherwise our build pipeline would be a lot more complicated. So this diagram really shows you how Jest uses Jest automatically to compile our TypeScript code to JavaScript before it runs the tests. And we're going to see that running now. So I'm switching into the 5th example now. Now, this is a project like, the TypeScript project we've seen previously, and also the Jest project that we've seen previously. Nothing hugely has changed. I think the test is exactly the same. Expect true to be truthy, so nothing complicated there. Again, it's still a hello world program. Nothing complicated there. The difference is going to be in our Nodemon, but let's have a quick look at package.json first. So in package.json, you can see we've got our dev dependencies set up for Jest, TS Node, TypeScript. Oops, TS Jest is a dependency. That should be a dev dependency. I've stuffed this up while I was building this. That needs to kind of move up to there. So I'll commit that later. So that's the way it should look. So we don't have any production dependencies because we're only looking at kind of development tools, in this talk. But otherwise, you'd also have plenty of other production dependencies if this was a real product. Now, in our scripts here, you can see we've got the same start and start dev commands that we had for our TypeScript example earlier. We've got a build command to build TypeScript. We've got test and test watch commands to run Jest. So what makes Jest run TypeScript code? Well, part of it is TS Jest that you can see down here in the dev dependencies. And the other part of it is in Jest, the Jest config, is it? Yep. So this is a case where I've actually changed some stuff here. So the first thing to notice is the preset for Jest is TS Jest. So that's what makes Jest understand TypeScript. It's that simple to configure Jest to use TypeScript these days. Like it used to be more difficult, but it's pretty simple now. Now the only problem that we've got, if we look in this directory here, there's a build directory, right? So this is where the JavaScript files, or this is where the TypeScript files get converted to JavaScript. So if you look in source, there's a TypeScript index.ts, that's a TypeScript file. When you run npm run build, which I did earlier in this project, that compiles it to JavaScript. Now the problem with this is that ordinarily Jest would, well, not in this case, but if we look under build test, you can see that there's an index.test.js there. And if we look under source test, you can see that there's an index.test.js there. So essentially, because we've built this project already locally, we've got a separate copy of it under the build directory. Jest doesn't know about that ordinarily. Jest will just say, oh, I'm going to run the tests from here, and I'm going to run the tests from here. And basically what it's going to do is run all your tests twice, which isn't great. So that's what on the right here in the Jest configuration file, that's why it's got this ignore patterns. So we're saying ignore anything that it finds, any tests that it finds under the build directory. We don't care about it running our JavaScript tests. We want it to run only our TypeScript tests. And it's a bit of a weird syntax here. Like I've had this discussion with people, like why is this kind of angle brackets root to needed there? Why isn't it just that, like or even just that? But it's in the docs. That's the way it works. I don't know why. But this is like essentially the same deal as before, right? You run npm test to it's going to run Jest for you. It's going to run your test suite once off. But the difference, of course, from the last example is now that it's running our tests, our code and tests directly from TypeScript. That is going to enable live reload. So it's watching our code for changes. So I can go in here, I can break the code and it's going to give you that big wall of red again. Yep. And I'll just set it, I'll get it to pass again. Cool. So what have we covered so far? We've covered Nodemon with Node.js, Nodemon and TypeScript. We had a quick look at how to configure Nodemon. We've looked at automated testing with Jest. We've looked at automated testing with Jest and TypeScript. We're going to move to the front end now. So the next example is live reload with Parcel. So Parcel is an easy to use front end bundler. It's going to take a collection of source assets like HTML, CSS, and JavaScript, and it's going to compile them into a static web page. And the web page that you build with Parcel can easily be copied to any web server and just served as simple files over HTTP. So I'm starting here with Parcel instead of Webpack because Parcel is so much easier. And basically for most use cases, it requires zero configuration. And it also has automatic support for live reload built in. So as you can see in the diagram here, we're going to use Parcel's built-in dev server to build our bundle, serve it as a web page, and then automatically reload our web page as we edit our code. So I think we're up to the 6th example here. I'm just going to open Visual Studio Code from there. And just a reminder again, like I only said this for the first example, but for each of these examples that you run, you have to do an npm install. Each of these examples is a complete standalone working project that you can install the dependencies for and run it separately. Okay, so looking in this project, what do we see? Let's start in package.json. So under our dev dependencies, the main thing here is Parcel. So we've got the Parcel bundler installed. And again, you can start a project like this real simple. It's just npm init-y. And in this case, npm install save dev Parcel. That will get this project started and set up. Not the code. I mean, there's a bit of code that has to be written. You'll see that in a moment. We've also got live server. So live server is not really essential, but I tend to use it for testing the production web page. So Parcel will you can use Parcel's dev server to run the web page in development with live reload. You can use the Parcel build command to actually build the static web page. And then once you've built it though, once you've built the production version, you can cd into the output directory for the static web page and run live server there. And it's got live reload as well. So essentially, if you're doing really simple web development, like with no build pipeline, live server is really cool because you can just code HTML, raw JavaScript, CSS, whatever, and it will do the live reload for you. So that's if you don't need a build pipeline or if you want to test like a production build. Now we've got a bunch of scripts here. As usual, the npm start command, which we want to be the most obvious operation. In this case, because we're never going to use any of these scripts to run this web page in production because it's going to be built to a static web page and deployed to like a HTTP server somewhere, right? So we never use any of these commands to run it in production. So you won't see a start : dev here. It's just not necessary. And instead, running it in development mode is just npm start. So to do that, we just run Parcel and we tell it which file is the entry point to our web page. Parcel can also bundle JavaScript files separately if you need to, but in this case, we're going to tell it to bundle HTML file, and it's going to grab all the assets that are underneath that as well. Now, to build the static web page, we'll run the Parcel build command. Now, I'm just going to run this directly from the command line here just to show you. It's going to be a little bit different. This is where it's going to be a little bit different depending on what operating system you're using. So I think for me to run this on Windows, I have to use, this is a bit weird because normally with Node.js, it doesn't really seem to matter much, but I'm going to use backslashes. So if you're on Mac OS or Linux and trying to do this, you'll have to use / instead. So I'm just starting up the Parcel development web server here. It should be pretty quick because I'm pretty sure I've run this in cache earlier on. There we go. So Parcel can be really quick to rebuild your project because it's got a really advanced automated sort of caching system. Let's have a quick look at what that looks like. I'll just put that off to the side there. So this is running the Parcel dev server with live reload. And we can actually change some stuff here. Like we can go into our HTML file and we can change something here. And you can see that it's just instantly changed. Zoom in a bit. So it's a pretty garish looking web page. I'll admit my front end design skills aren't very good. I can do everything. I just can't make it look beautiful. But let's change it back. So hello world. So this is what a HTML file looks like that's going to be bundled with Parcel. It's no different to any other HTML file. And we're telling it, to include some JavaScript, include some CSS, and then it bundles it. Actually, I'll do a build. I'll do a build just so you can see what it looks like when it's bundled. And you can change, you can change the code in your JavaScript, HTML, CSS, whatever you change that Parcel can see. It's going to live reload your web page to show you the result. So I probably already built this. It's built under the dist directory. So if I run npm run build, so that's what's running this build script. You can see over here, Parcel build, and you give it the entry point to your web page. Hopefully it's not going to take too long. So if we look under the dist directory, there's probably all sorts of kind of cruft here. There's too much cruft there really because I've built this multiple times. But let me just delete that. I'll build it again just so you can see what the output looks like when it's built for production. So you only got like a handful of files there. And then if you wanted to test that production web page, you could go in here, and because I've got live server installed, I can run live server. So npx again is the command that comes with Node.js that allows you to run local packages without having to have any global packages installed. And so you can see here, this is like the production build of the web page. And if we look at the code for that, Parcel is going to have minified it. And you look at the code, and it's all kind of crunched up. But the important thing is that Parcel comes with built-in support for live reload, and it requires literally no configuration. There is no Parcel configuration to show you in this project. That's not to say that I can't add one. You can add a Parcel configuration file if you've got something you need to configure. But like I've literally never had to do that with Parcel. It's just that good out of the box. Now, let's move on to the next example. I'm just going to breeze through quickly live reloaded with Webpack because Webpack is kind of complicated, as you probably know. If you don't know what Webpack is, it's another bundler. So it's a bit like Parcel. It's going to kind of take your assets, bundle them together so you can have a build pipeline and build all your code into a static web page. And again, you could use it with JavaScript or TypeScript. I didn't show you TypeScript with Parcel. I do have an example of Parcel plus TypeScript on my GitHub. If you want to look at that, it's like super simple to set up. Now, Webpack, as I said, it's a lot more complicated than Parcel. That off the bat, you need a configuration file. You need to know how that works, how you're going to configure that. And live reload, surprisingly, doesn't work right out of the box. And I'll show you what I had to do to configure that to make it work. So this diagram shows how we're going to use the Webpack Dev Server. So the Webpack Dev Server is actually a separate thing you install on top of Webpack. So it's an optional extra. With Parcel, the Dev Server is included. So it's another thing I like about Parcel. But it's the Webpack Dev Server that's going to watch our code for changes and trigger the Webpack CLI to rebuild our bundle. And automatically, the Dev Server automatically refreshes the browser to update our web page. So let's have a quick look at this. We should be up to example number 7 now, I think. Yep, front end with Webpack. And again, with any of these examples, you've got to run npm install before you can use it. I'm just going to breeze over this one really quickly. Hopefully you know all this stuff. There's a bunch of dependencies installed that it needs for this to work. There's a bunch of scripts that you can run. So there's a build script to build the production website. There's a start script. Again, we don't need a start dev script. We only need just a simple start script in this case. We're telling Webpack to serve our page and open the browser to that page. I mentioned you've got to have the Webpack Dev Server installed separately. It's not kind of built into Webpack. And that's what allows you to run this serve command. Now, for you to use live reload with Webpack, you need to turn off hot module replacement. So let me try and explain this. So live reloading the whole page works with Webpack, but only if you turn off hot module replacement. Now, hot module replacement is a more advanced feature that's a lot more difficult to configure and get working with Webpack, where instead of reloading the whole web page, it'll reload particular code modules or particular particular assets within the bundle without having to refresh the entire browser. So hot module, can't remember whether it's hot module replacement or hot module reload, but HMR is the acronym. It's a lot more difficult to configure, but if you just turn it off, that makes live reload work for Webpack. So you just have to know to do that for a live reload, like whole page refresh. And I've found that, and I've been through the hassle of configuring HMR, and it's hard work, keeping it working. But live reload in Webpack, if you turn off HMR, like this line of code here, if you do that, I just found it works really well on most projects, and you don't even need HMR. So if you've got a big complex web page, maybe HMR is what you need, but otherwise just stick with live reload in whole page refresh in Webpack, and it's probably going to do pretty much everything what you need, hopefully. Okay, so now we're coming back to the back end, but this time we're going to be looking at Node.js running within a Docker container. And you might be surprised to learn that you can use live reload within a Docker container. You need to have a slightly sophisticated build pipeline to achieve this. But if you know Docker already, if you don't know Docker, you're probably going to be bamboozled by what I'm about to show you, whatever the case. But if you already know Docker, you might be surprised at how simple this can be. And it means you can scale up live reload to a larger microservices application. And again, live reload, it's only something that we want to use in development, but it can be very useful that when you have like a microservices application running on your development PC under Docker Compose, probably, which is what I'm going to show you, and then be able to edit the code for any given microservice, and then have that microservice automatically restart, like on its own, just it knows to restart, and only that microservice as well. So it's not like you're forcing all your microservices to redeploy or re-update. It's very efficient that way. Okay, so the good news is that we already kind of have all the tools that we need for this. So we're going to use Nodemon, just like we did back in example 1, to restart our Node.js application. But this time we're going to be running it within a Docker container. And as you can see in this diagram, the biggest part of the puzzle really is how do we share our source code kind of live, as it were, from our development PC into our container. So that means if we can do that, if we can share our code between the development PC and the container, that means we can get our code changes quickly across to our container and have our application in our container restart really quickly. So let's have a look at how to do that. Come on, computer. What are you doing? There we go. Okay, so we're up to example number 8. I'm just going to open that in Visual Studio Code. We're just going to run this right off the bat. It's all under Docker Compose. Docker Compose up. Make sure we build the Docker files before we run it. I've built this all before, so it should only take a moment to start. While that's starting anyway, oh, there it is, that's good. So you can see we're running our Node.js application with Hello World. Again, just super simple code, nothing complicated in the code. Now, if we look at this project, you could think of this as like a mono repo for microservices, or maybe even a meta repo. It's only got one microservice. So it's a simple example. It could have more. This could be microservice 1, we could have microservice 2, however many microservices we need for our application. We're tying them together with a Docker Compose file. So the Docker Compose file is what defines our microservice and tells it where to find the Docker file for it and a few other things here. Now, if we had more microservices, we'd kind of replicate that and we'd call it like microservice A, microservice B, so on. We can have as many sections as we like in here. Now, I've already got live reload working. So let me just go into the source file, and I'll do my usual thing, and I'll just change it to Hello Computer. And you can see on the left here that the Docker container is restarting, and it said Hello Computer now. So we've got the same thing as before, but now we're running it in a Docker container. Now, what is the thing that makes this work? Well, to start with, it's the Docker file. So you can see here that I've called the Docker file -dev. So normally I would have a dev Docker file and a prod Docker file. So like I said, the needs of development and production are pretty different. So I want to have two separate Docker files for that. I only need to show you my dev Docker file here for this one tonight. So let's just have a look at that. Now, the important thing is here is this npm run start dev or start:dev. So that's what we saw in the first example. That's what we do to run our Node.js application in live reload mode. You can drill down if you want to see how that works. Again, if you want a refresher, you can just go down into the package file and look at the start dev command script that's in here, and you can see that's running Nodemon. Now, in this case, we're running it slightly differently. We've got this legacy watch argument here. Now, the reason for that is normally when you run Nodemon on your desktop PC, on your development PC, it's going to use the features built into your file system to automatically kind of like an event-driven kind of notification that a file has changed. So Nodemon normally is very efficient. Unfortunately, that doesn't work too well in a Docker container, at least as far as I can see. But if you use legacy watch, that's going to put it in polling mode. So it's constantly polling for changes to the code, and that's how it's going to know the code's changed and to restart your Node.js application. So that's just something you need to kind of run this in a Docker container or in a virtual machine. Like back in the old days when I was running Vagrant virtual machines, I used this same basic setup. I had to get Nodemon to poll for changes inside the VM. Now, so that is the Docker file. So that's what we use to build it. And if we look back at the Docker Compose, you can see that it's the Docker file it's referencing here is that Docker file dev in the context of the microservice subdirectory. So that's how it's finding that Docker file. Now, the other thing you need here to get this to work is you need to be able to share your code from your development PC. So this code here, so this index.js, like this is on my development PC, but the container's like, in a whole other world, basically. How do I get the code, besides copying the code into it through a Docker file, how do I get the code there? Well, the answer is to use Docker volumes. And they're really easy to configure through a Docker Compose file. So you can configure this on the command line with Docker if you want, if you're a sucker for punishment. But it's really easy just to put the directories that you want to synchronize automatically, through to your container, list them under the volumes directory here for each microservice. So this first one here kind of shares the npm cache from your development PC through to the container, and that makes installing node modules, npm install, inside a container really fast, or at least when they're cached. And then the second one here is what shares the source code. So this is what shares the source code from this local microservice / source subdirectory into the source directory inside the Docker container. So that's how you get live reload working in a Docker container. Just two parts to it, really. It's the make sure you're running the right command in your Docker file, which is the command that we used earlier in example 1. And then in your Docker Compose file, make sure you're sharing your code across. So the important thing to note in this Docker dev file, right, is that normally in a normal Docker file, you'd see like something like, copy source over to app source or something like that, right? Or copy source to the source subdirectory, right? That would bake the code into this Docker image. But we don't have anything like that here. That's just gone. We're basically relying on that shared volume to get the code into the container in the first place. So the code in the container is effectively mutable, which is the opposite of what you want in production. But for development, it works wonders. You can imagine here that I could have 20 microservices in this project, and I could have them all running on the left here, and I could be editing the code for any of them, and only that microservice that I edit will change, will automatically reload. So I think that's about it. Now, there is another example here. I'm not going to go into it. Yep, so I'll leave you to go and to have a play with this example for yourself, and it'll be included in my blog post as well. This example basically shows you how to kind of get your TypeScript code to automatically live reload in a Docker container. And again, it's simpler than you might think because it's building on all those other examples that we've looked at. So simple stepping stones above what you've seen already. So tonight we've had an overview of how to use live reload techniques across your entire stack to help you build a streamlined and fast-paced development process. But there's so much more to learn to being a fast developer, and that's why I'm writing my book, Rapid Full Stack Development. Please join me on Twitter for updated content and news about my book, and that's it. I don't know how I was going to ever keep that talk to 30 minutes. So I'm kind of lucky that it turned out the way it did tonight.
You did great, mate. Thank you so much for that. You've obviously packed in the content, and I think it's been really valuable to everyone there. We've even got a few questions, would you believe it or not?
Sweet.
So we'll start with the one that's not anonymous. We've got Rob, who's jumped in and asked, what are the diagrams created with Excalidraw or Rough.js?
Yeah, I haven't heard of Rough.js. I'm going to look at that one though now. But yeah, Excalidraw is sort of my go-to there because nice. I'm a terrible artist, so I can't draw those things myself. I only wish I could.
Artistry can be with code too. There's absolutely no requirement that it must be a visual medium. So yeah, let's get into some of the other ones. There's 3 more here. When Jest in watch passes all the tests, will it reload the node application? I think that might have been some nuance that we needed to highlight.
Yeah, so the system for doing live reload for your application is completely separate to the system for doing live reload for your automated testing. So when you run Nodemon, that's one thing. And when you run Jest in watch mode, that's a completely separate thing. And we use, typically when you're running Jest, you want it to see any changes in any of your code across your application. So any of the code that you're testing, any of the code that does the testing, if any of that changes, you want Jest to reload. So it watches it. Jest essentially watches everything, except for the TypeScript example where I showed you the build directory. It doesn't watch that, but I have to explicitly make it ignore that. But Jest basically watches all your code for changes, and if anything changes, it reruns. When Nodemon, we don't want it touching our tests. Like it's just kind of it's not as efficient to have it kind of monitoring your tests because Nodemon is just there to run the application. And that's all you want it looking at. You want to look at the code for the application, not the tests, and have it intelligently kind of restart if any of that code changes. But Jest is not. They're not related. So Nodemon and Jest are not related. You're using them on some of the same code, but they're completely independent and they're doing slightly different things. But they're making use of live reload, which is the ability to watch your code and then redo whatever it does. And like I said with Nodemon, it's like really flexible as well. So like I've made data processing pipelines where kind of you have a bunch of CSV files and you tell it to watch CSV files and trigger some code that when there's new data coming in. So it's a quick and dirty way to make like a live data pipeline. But again, separate systems for separate purposes.
Awesome, that's great. One of the other ones that was here was, does TS Node have an advantage over running against the compiled? Excuse me, try that again. Does TS Node have an advantage over running against the compiled output being served up to Node?
It's just a little bit more convenient. So if you wanted to implement live reload without TS Node, so TS Node's, regardless of live reload, TS Node is fairly convenient. Because otherwise, every time you change your code, you've got to rebuild the JavaScript, and then you've got to go and rerun the JavaScript. So you've essentially got 2 steps to run your code. So TS Node, even though it's not the best performance in the world, it is slightly faster than that kind of manual compilation of code and then restarting the compiled code. So it's slightly more convenient, slightly faster than doing that, even without live reload. Now, with live reload in the picture, if you didn't use TS Node, you'd have a much more complicated build pipeline because you'd have to have you'd be running TypeScript, the TypeScript compiler in watch mode in parallel to probably still using Nodemon or something similar to rerun Node.js on the compiled files. So you've got more complicated build pipeline, there's more work to get that started, more work to keep it running. It's just easier to use TS Node. So TS Node, it's really just about convenience, but it's not essential. In fact, I was making the point today to someone on Twitter that if you ever feel overwhelmed by the vast number of tools that we have in JavaScript, if you're ever overwhelmed by this massive ecosystem, just do a little thought experiment and think of everything on NPM as an optional extra. Like all you really need is Node or the browser and maybe Notepad. Like no one works that way, of course, and maybe less you're just starting out with it, which is a perfectly legitimate way to start learning development. But no one professionally works that way. It's just a thought experiment that, none of these things are really needed. You can always find a way to work without them.
Absolutely. Yeah, that's good. The last one's a bit of an expanded question. I think it's on the coding cycle unfolded slide. Can we also add a if Friday don't deploy flow?
Yeah, I mean, all this is development only. It's got nothing to do with production or deployments or anything like that. But yeah. You should be deploying to production continuously anyway. Like anytime code changes and passes the test, it should go out. That's the dream anyway.
Yeah. Or whatever gateway process you have, it needs to be as close to production as possible, so that you can get there. Absolutely. So that's fantastic. That's the questions we'd amassed. I was just going to check the live stream page to make sure I didn't miss anyone's questions in there. We've got we obviously want to see all the vulnerabilities patched in your demo projects for one reason or another. It's just run npm audit fix, everyone's really grateful and saying thank you. So there you go. So rough.js is underneath Excalibur. It's part of the secret sauce. Learned something new. Thank you, Robert. That's fantastic.
Thank you for that. I'm going to look up rough.js. Sounds really cool.
Awesome. All right. So it's a bit of a short one today, but obviously, quick but good. And we've got some extra content out of Ashley. So that's always a good thing. So thanks very much. And we'll get everyone the links and interesting tidbits that Ashley's managed to share. And you can run some of those demo projects yourself at some point as well, which would be really fun, especially if you're getting interested in some of these different tools and pipelines and trying to test out running your tests, for example, something that we all want to do and make sure that we make second nature. But yeah, that's awesome. Thank you very much.
Thanks,
audible applause for you, virtual event style. I'm gonna throw my slide up here again and